8-inch by 8-inch block heat test using a propane torch. $13.47 hours. So here we are, 1/2 hour into the burn test. Let's see if we get a shot of 14, 17 hours. You'll notice that the only damage we have to the block is that red hot glowing area in the middle of the block caused by the propane torch. So what I'm going to do now is we are going to measure the temperature in increments of 1 inch through this 8-inch block starting from the back. So if you can see there, the ambient temperature is about 44.7 to 49 degrees. You can see that the temperature will go up when I get it close, the probe close to the heat source. And when I take it away, it drops back to the ambient temperature. So once you get it back down to about 47, 48 degrees, I'll start back. Let's try it at the 6-inch mark. There we go, now it's dropping down. And we see that the temperature hasn't changed. Maybe 1 degree, no, 48. So no heat has transferred through 6 inches of the block. Let's try 5 inches. So at 5 inches, we're still at about 47, 48 degrees Fahrenheit. So at 5 inches, no heat is transferred from that glowing orange, reddish ball in the middle of the block. This is after 1/2 hour with the torch aimed directly in the center of the block. Let's try 4 inches. There we are at 4 inches. Still we're at about ambient temperature. Actually, it's registering a little bit cooler because it's getting cooler outside. Let's try 3 inches. At 3 inches, it actually went up about 4 degrees, 4 to 5 degrees. Let's try 2 inches. Now you can see the temperature is increasing significantly. We're up to about 100 degrees. 102 degrees. That's 2 inches in from the block. Again, the bottom of the probe would line up directly with the center of the heat source. Let's go to 1 inch. 1 inch into the block. We're about 170, 171 degrees Fahrenheit. That's 1 inch into this 8-inch block of composite. Now, how hot is it at the heat source? and we're reading 1800 degrees at the heat source. So if you look at the watch, 14:48, just a tad bit over 1 hour. You can see that the block is still maintaining its integrity. Nothing has changed. We'll take the temperature again, and this time we'll just start at about 5 inches. You can see the ambient temperature is about 44 degrees. Put it in at the 5-inch mark. It went up 2 degrees. That's about halfway through the block, a little bit more. And it went up 2 degrees. Let's try it 4 inches. It's at 49 degrees. So it's just a degree or two warmer. Let's try it at 3 inches. Remember, this is after 1 hour of cook time. We're up to about 71, 72 degrees, 73 degrees. So we're getting some heat transfer. So at 4 inches we're at about 50, 51 degrees. So that's up about 5 or 6 degrees from ambient temperature. We broke the probe. So I accidentally pulled the tip of the probe apart, so it's no longer registering. But you could see at 3 inches the temperature was about 73 degrees, and that's from the initial heat source of 17 to 1800 degrees. So obviously the composite material is deflecting and reflecting almost all of the heat back to the surface, and it's maintaining its integrity. So we'll keep burning it as long as we have sunlight. Remember, this is after 1 hour of burn time. After 1 hour of burn time, the block still maintains its integrity, and the temperature only rises about 30 degrees from the surface of the block to 3 inches in. So we're going to zoom in on the watch again. You'll see that it is about an hour and a half into the burn. We started at 13:47. It is now almost 17 hours. And as you can see, after an hour and a half of burn time, nothing has really changed. I broke the probe on my heat sensor, but I've got something even better. I'll just put my hand on the block. It's nice and warm. It's barely above ambient temperature right on the crest here. And coming even a little bit down. You can see I'm pressing into the block. I'm inches from the red hot spot there at the heat source, just an inch or two. And I got my hand up against it. This dissipates heat real well. See, no damage to my hand. We'll check in again at 2 hours. So here we are at about 2 hours, just a little over 2 hours. Zoom in on my watch. 15:49 hours. We started at 13:47 hours. Again, there's no compromise to the block. It's maintaining its integrity. And unfortunately, I broke my probe to my peak meter. But what I can do is I can put my hand on this. The ambient temperature is 41 degrees Fahrenheit. A little bit chilly. But I got my hand on the block. And the whole point of this demonstration is to show that this composite material reflects the heat back out. It does not burn. I'll put my thumb right there. Look at that. Now that's a little warm there. I can hold it on there for probably a few minutes, but I'm getting the heat coming up. I'll put it over here. This composite material does not burn. It reflects the heat back out. It will not let the heat through. So here we are at 2.5 hours. I'll zoom in on the watch. 15 hours. That's 2.5 hours of burn time. And as you can see, nothing has really changed. I can put my hand on the block just inches away from the heat source. I can tell by the touch that it's a little bit warm here. It's probably about 70 degrees. Back in the back part of the block, it's ambient temperature, which right now it's about 40 degrees out, 40 degrees Fahrenheit. That's at 2.5 hours. We'll try again a little later. So here we are at 3 hours of burn time, and I'm running out of sunlight. Actually ran out of sunlight, but you can see my watch there. 16:47 hours. We started at 13:47 hours. And again, I can put my hand on the block. It's warm right in this area. It's cool on the back, which means it's probably ambient temperature on the back. I could put my hand just inches from the flame, from the heat source. No damage done to my hand. So that's 3 hours of burn time. The block maintains its integrity. It does not burn. This material does not burn. And tomorrow I'm going to take a hammer to it, at least to this face area, just to see how deep the flame went into the block. Again, 3 hours burn time. I could have this thing burning all night. I'd come out in the morning and find basically what you're seeing here.
So yesterday we subjected the composite block to 3 hours of some pretty serious burn time. Today we're going to put it through a different torture test. We're going to hit it with a 50-pound iron block, you see to the right of the composite block. Then I'm going to hit it with 2 hammers, a framing hammer and a sledgehammer. The current ambient temperature is about 40 degrees. I only bring that up because it was freezing last night. So the block was subjected to a wide range of temperature, from about 1800 degrees at the heat source yesterday to 32 degrees, give or take a degree, last night. That should produce a wide variation of expansion and contraction by the block, which would add to the stressors applied to the block. I would encourage you to watch the videos where we subject these 8-inch thick blocks to a variety of high-power ammunitions, including .30 caliber high-powered long rifle, 12-gauge shotgun, and assault rifle 5.56 with green tip NATO ammunition, that's armor piercing, and also my favorite, where we hit the block with a .50 caliber sniper rifle at about 10 yards, shooting a 6.60 grain .50 caliber BMG. So now in completion of this torture test, I'm going to first take that 50-pound iron block and drop it on the 8x8x8-inch composite block from about 2 feet.
Three, two, one. If you happen to miss that, we're going to try it one more time. 50-pound iron block from about 2 feet up. 3, 2, 1. It's obvious that the block is holding its integrity, so we'll try a sledgehammer. I'm seeing some cracks beginning to form, but this thing is taking a lot of abuse. Now I'm going to focus right where the heat source was placed for 3 hours and see just how deep the burn went into the block. So if you're able to see that, it looks like I was able to penetrate into the block between 3/8 of an inch to a 1/2 inch. That's all the farther this block had been compromised. So I'm thinking that this material will hold up well in any type of fire that it could be subjected to. In other words, if you had a shed or a building or a house or a barracks built out of this stuff, it could withstand tremendous heat, tremendous fire, tremendous damage, and maintain its integrity. And just because I can, I'm now going to finish off the block and torment it some more with my sledgehammer. I'm going to hit it till it totally falls apart. This will allow you to see what kind of damage it can take. And there you have it. So there's one more feature I want to show you concerning this composite block. You can see it's going to make an excellent building material for sheds, shops, houses, buildings, anywhere there is substantial risk to fires. Think of the LA fires where entire neighborhoods burned to the ground. This building material would provide structure which would have defeated those fires. A house built of this material would still be standing. And I'll remind you that this composite material was originally designed as a building material that could be used in structures designed to defeat high-powered munitions. And as I have mentioned earlier, we have video of an 8-inch thick block. This is an 8-inch thick block right here, with a heavier grade mixed in, defeating a .50 caliber from a sniper rifle at 10 yards. So any building built out of this material is going to be formidable. The feature I want to show you here is that you can drill into this material, you can nail into it, you can glue to it. So if you wanted to add any type of siding, in this case we got some hardy board, which is also flame resistant and does not burn, then you're able to do so by whatever means you want to attach it to this block. So I'll demonstrate that now. This is a pneumatic coil roofing nailer. And I'm going to show you that it receives the roofing nails quite easily. Now this first block actually has a heavier grade aggregate mixed in, and it still took the nails. So it'd be easy to conclude that would take nails, a pneumatic framing gun or a staple gun. As you can see in the back block, I've actually got a wood screw already screwed in here, but you can see what that means is if you were to build a house, shed, building, barracks out of this material, you could add siding of your choice without having to add any other type of materials to the block to secure it to. And this sets it apart from concrete buildings, brick or rock buildings. And with the advanced composite sidings, you'll come away with a building that's even more fireproof.